Hey everyone, my name is Karthik. Welcome back to my channel. Today we are going to explore a super interesting topic in the world, search and AI, hybrid retrieval, BM25 versus dense embedding. Now I am going to share about the project. Okay. See here, we can see our main project, hybrid retrieval, BM25 versus dense embedding. If you ever wondered how search engines like Google Search and ChatGPT find the most relevant results for your queries, this video will help to make crystal clear. By the end, you understand what BM25 is, what dense embedding, and how combining both this gives a smarter context-aware search results. So let's move on to the next part. Here you can see the introduction problem statement. Introduction part is information retrieval, the goal is simple to find the most relevant content from a massive collection of documents. Traditionally, search engine relied on keywords based methods. One of the best known one is BM25, which looks for exact word matches between your query and document. But in recent years, deep learning has completely changed in the game. Instead of focusing on exact words, models on understanding meanings, they use something called like dense embeddings to capture the semantic relations between the text. However, both methods have their own strength, weakness, and exactly why we bring them together. It is called as hybrid retrieval. Now we are going to see the problem statement. Let us define our problem. When we rely on the BM25, we get fast and precious keywords matches, but it struggles when people use synonyms their questions. For example, search for automobiles insurance might not show results about car insurance because the exact word doesn't match. On other hand, dense model understand the car and automobile means the same thing, but they are computationally expensive and sometimes they ignore exact keywords that really matters, like medicine names or product codes. So the goal is to combine both to get the accuracy of BM25 and the context awareness of dense embeddings. Here you can see the problem statements like the goal is to combine both BM25 and dense retrieval to achieve optimal balance between the precision and context. Next goal we are going to have what is BM25? It is a lexical search. It ranks the document based on keywords overlap. And we can see the formula here like score DQ is equal to sigma of IDF into FTD into K plus 1 by FTD plus K into L minus B plus B into D by average of D. And it has some advantages like simple and efficient for exact matches, performs well on short queries, but and it has some limitations like ignoring semantic similarities. Example, iPhone not equal to some smartphone, old overlapping dishonors. Next, we are going to know about what is dense embeddings. It is a semantic search. It is an retrieval uses deep learning model like Sentence-BERT to convert text into vector embeddings. Cosine similarity between vectors measures meaning similarity. Example, a new iPhone releases 0.23 to 0.45, 0.87. Latest iPhone 0.21, 0.47, 0.85. Even without share words, the embeddings are close semantic related. Now here you can see this approach uses deep learning models like Sentence-BERT to convert each sentence. So dense retrieval model can find contextual relevant documents even when the words doesn't match exactly. However, they are computationally expensive. Encoding, comparing, strong, and storing this vector takes a lot of resources. Now we are going to see what is hybrid retrieval. The best of both words. Here we are going to combine both the BM25 and dense embedding. Here we can see this. We take the BM25 score and the dense embedding score for each document and combine them both. Here you can formula hybrid score equal to alpha into BM25 plus 1 minus alpha into dense. Here alpha is balance between lexical and semantic relevance. It gives a result like a ranking system that handles both keywords, precision, and semantic understanding. This is exact technique used in modern search systems like ElasticSearch with HuggingFace embedding, which combine traditional indexing with AI power meaning. Now we are going to look into the algorithm that we're going to use to solve this problem. Here we can see the algorithm. In this, we have tokenized compute BM25 score using something like BM25 K API, compute embedding for both query and document using a model like sentence transfer. And fourth step, we are going to see calculate cosine similarity between the queries and document and embedding. Fifth step, we are going to see normalize both BM25 and dense score to 0 to 1 scale. In sixth step, we are going to combine the both formulas with alpha. And seventh step, we are going to sort by hybrid scores and then return the top results. In this, we can see that combinational allows system to rank documents that not only contains the right words, but also mean the right thing. Now we are going to see the solution. Now I am going to share the solution for this. Here the solution. Here we can see the solution. We have taken the query latest Apple smartphone, and we have some documents like Apple D1, D2, D3, D4, D5, D6. And first step we have done tokenizations and taken latest Apple smartphone. Three tokens we have there. And second step we are going to calculate the BM25, and where here you can see the calculations part and Apple smartphone and Apple. Here you see the values, raw values and normalized values. In step 3, we can go into use a dense embedding. Each text is embedded using sentence transform like all minimum L6 V2. And we can see the example like value cosine score and normalized dense score. In step 4, we are going to calculate the hybrid score calculations. Here you can see the hybrid score 0.85 for D1, D2, 0.89, 0.49 for D3, 0.21 for D4, 0.07 for D5, 0.06 for D6. Here we can see rankings, final rankings for each documents. We got the D2 first rank, D1 second rank, D6 third rank, D4 fourth rank, D5 fifth rank, D3 sixth rank. And finally, we go into analysis. Based on these results, we are going to analysis what is going to happen. See here, you can see the we got for D1, D2 0.0808 and D2 0.87. It is a solution for the above problem statement. Now I'm going to share the slides. Here we can see next is the visual analysis. In this visual analysis, we can see clearly the bar graph and the scatter plot. In bar graph, you have taken the BM25 versus dense versus hybrid scores. It shows the how hybrid achieves balanced ranking. In scatter plot, we have taken the correlation between the BM25 and dense score. It illustrates the divergence between lexical and semantic matching. Hybrid retrieval bridges both space effectively. Now we are going to see the bar graph and the scatter plot. Here you can see the bar graphs. First one, the blue color indicates the BM25 score, and next one, dense, it indicates a dense score, and green indicates the hybrid score. Hybrid score is a both combination of BM25 and dense score, so it gives like an average. Here you can see the top towers in bar graph. Here you can see the scatter plot. It gives a correlation at 0.00. BM25 has 0.0 and document D6 are both 0. But D5 has some value 0. Like 0, 0.1 like that, and D4 has 0.4, and D3 has 0.41, and D1 has 0.61. Last final D2 has 1. Final results on the problem statement by using the solution. We got this results. Here, what we have learned from the results is B is the grade for short, exact keyword queries. Then small is excel at understanding rephrased or conceptual queries. Hybrid retrieval delivers the most conceptual accuracy result overall. So it gives how powerful it is in bridging the lexical and semantic space together. Now we are going to finally conclude. Hybrid retrieval units the both BM25 keywords precision with dense embedded system. Smarter context aware search, easy integration into ElasticSearch, suitable for real world applications like search engine, chatbots, QA systems, etc. Like future works like we can optimize a alpha weighted dynamically, use re-rank transform like collaborate, deploy hybrid pipelines in production search systems, and dynamically turn a alpha query type using a re-rank, etc. This is the main part. Now I'm going to end this video. That's it for today video. If you found this helpful, don't forget to like, subscribe, and share it with your friends who's love and data science, who's love AI and data scientists. Thanks for watching. This is Dinesh signing off. See you in next video.